Assalamu alaikum, my dear students. So we will discuss another different type of base catalyzed condensation reaction, which is called Knoevenagel reaction. So what are the reagents for Knoevenagel reaction? In Knoevenagel reaction, we will react malonic ester with an aldehyde, and preferably this aldehyde will be aromatic aldehyde. Preferably. However, reaction will take place with aliphatic, but preferably we will carry out the reaction with aromatic aldehyde so that reaction will not take place further. So what one reagent is malonic ester and the other is aromatic aldehyde and takes place in a special type of base which is called piperidine. So now I will tell you that why we use a piperidine. So as you know that malonic ester is a special type of ester in which this alpha carbon is highly activated. Why? Because two ester groups are present, so both ester groups are activating this methyl group, and when the carbene ion is formed here, this carbene ion is activated on this side and also on this side delocalized, so this carbene ion is very easily formed. So due to this reason we will use a very weak base. With a very weak base you can remove this proton. So piperidine, this is a piperidine, a 6-membered ring with NH, so this piperidine is used with a very much weaker base. So this very much weaker base will do its function and will remove the proton. So when you treat malonic ester with piperidine, so the carbon is alpha carbon is converted into carbene ion, and now this carbene ion attack on this aldehyde. Reaction will not take place with a ketone. I will tell you at the end why ketone will not react. So this carbene ion attack on this aldehyde, carbon and carbon, oxygen, negative charge goes to oxygen, and then oxygen will abstract the proton from this base. This base abstracts the proton from here, and then this oxygen will take the proton from this base which had a proton, and so this one is converted into OH. So at the end, in the presence of basic conditions, this proton and OH is removed and you will have a double bond here. So in this way, the malonic ester 1, 2, 3 carbon is attached with aldehyde compound and you will get this compound. However, if you carry out reaction with aldehyde with carboxylic acid, malonic acid, reaction also takes place. Go in the same piperidine base, the base will remove the proton. This carbene ion will attack on this carbon, and this carbon will have a O negative charge, will abstract the proton from base, and you will have this compound. Now in this step, the carboxylic acid is removed, and you will have a compound with this one carboxylic acid. In malonic ester, both ester will be removed, will be present, but in carboxylic acid, one carboxylic acid will be removed, other will remain. So aldehyde will also carry out reaction with malonic acids. Now, why the ketone will not react? Because ketone has very less activated carbon, so this malonic ester carbon will not attack on the keto, and keto is also acidically hindered, so keto group will not react with malonic esters. So Knoevenagel reaction takes place only with aldehydes, preferably with aromatic aldehydes, and with malonic esters or malonic acids in the presence of a special base which is called piperidine to give you this product in which the aldehydes and malonic esters attach with each other, and you will get the enlarged and lengthened chain. Assalamu alaikum, my dear students. So we will discuss the last type of base catalyzed condensation reaction, which is called Claisen condensation. So it is the last type of reaction which is included in your syllabus for base catalyzed condensation reaction. So after that we will start the acid catalyzed condensation reactions. So you will not confuse this Claisen condensation reaction with Claisen reaction. You have already discussed the Claisen reaction in which the acetoacetic ester react with benzaldehyde. So that reaction was called as Claisen reaction. But this reaction is called Claisen condensation reaction. In this reaction, it is the self-condensation reaction of the ethyl acetate with in the presence of ethoxide anion. So it is also a very useful method for the formation of acetoacetic ester. You know acetoacetic ester was ester which contains a group CH2 which is catalyzed by two CO groups. One was malonic ester and the other is acetoacetic ester. Here on this side was ester and there was this side there was keto group. So it is called acetoacetic ester. So this method is a useful method for the formation of acetoacetic ester. So now we come to the mechanism. What happens? when you will use ethyl acetate and you treat this one with the base ethoxydenine, the base will remove the proton from this carbanion is formed from the alpha carbon, and this carbanion will attack another molecule of ethyl acetate. In this case, we will not add some other reagents. We will use only ethyl acetate and a base. So this carbanion will attack another molecule of the ester. The negative charge comes to oxygen and a carbon-carbon bond is formed here. When this negative charge comes back, the ester is removed and you will get the acetoacetic ester. Very simple reaction, but this reaction must not be confused with another reaction which is called Claisen reaction. So in Claisen reaction, the ester will react with benzaldehyde, but in this Claisen condensation, the ethyl acetate react itself to give you the acetoacetic ester. So it is the end of the base catalyzed condensation reactions.